Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. Welcome to Thermodynamic lecture series. Today we are going to discuss the properties of pure substance, that is chapter number 3 of the book Thermodynamics in Engineering Approach by Cengel and Boles. Objectives of the lecture are: first we will discuss that what is pure substance, we will define the pure substance, and then we will talk about the phase change processes, that how we can define phase change process and how it take place. Saturation, temperature and pressure will be discussed. Also, latent heat and sensible heat will be differentiated, and finally thermodynamic properties diagram will be discussed. Different thermodynamic properties diagram like TV, PV for pure substance we will study. So first of all, what is pure substance? So a substance that has a fixed chemical composition throughout is called a pure substance. For example, water, nitrogen, helium and carbon dioxide are all pure substances. A pure substance doesn't have to be of a single chemical element or compound. However, a mixture of various chemical elements or compounds also qualifies as a pure substance as long as the mixture is homogeneous. Air, for example, is a mixture of several gases, but it is often considered to be a pure substance because it has a uniform chemical composition. Phases of a pure substance. At room temperature and pressure, copper is a solid, mercury is a liquid, and nitrogen is a gas. Under different conditions, each may appear in a different phase. By changing the condition, the phase of the respective substance may change. Even though there are three principal phases, which is called solid, liquid and gas. A substance may have several phases within a principal phase, each with a different molecular structure. Carbon, for example, may exist as a graphite or diamond in the solid phase, which are the allotropic forms of carbon. Helium has two liquid phases. Similarly, iron has three solid phases. And ice may exist at 7 different phases at high pressures. A phase is identified as having a distinct molecular arrangement that is homogeneous throughout and separated from the others by easily identifiable boundary surfaces. So this is the main thing which we have to focus on, that how we can identify the phase of a substance. Examples of pure substance, just like we discussed, is nitrogen and air. A mixture of liquid and gaseous water is a pure substance, but a mixture of liquid and gaseous air is not. So, phase change processes of pure substances. There are many practical situations where two phases of a pure substance coexist. For example, water exists as a mixture of liquid and vapor in the boiler and in the condenser of a steam power plant. Similarly, the refrigerant turns from liquid to vapor in the freezer of a refrigerator. There are various phases of a pure substance. So how these phases can be defined? First of all, what is compressed liquid and saturated liquid? Consider a piston cylinder device containing liquid at 20 degrees centigrade and 1 atm pressure. For example, this is the figure 3.6. At 1 atm and 20 degrees centigrade, water exists in the liquid phase. So under these conditions, water exists in the liquid phase, and it is called a compressed liquid or a subcooled liquid. There are two terms which are used alternatively. One is called compressed liquid and second is called subcooled liquid. So at these conditions, 20 degrees centigrade and 1 atm pressure, this water exists as a compressed liquid or a subcooled liquid. What is saturated liquid? A liquid that is about to vaporize is called saturated liquid. So for example, looking to figure 3.7, at 1 atm pressure and 100 degrees centigrade, water exists as a liquid that is ready to vaporize, because from 100 degrees centigrade we know that boiling starts, so it is about to vaporize. So at this phase it is called saturated liquid. Saturated vapor and superheated vapor. A vapor that is about to condense is called saturated vapor. A substance at states between 2 and 4 is referred to as saturated liquid vapor. This state 2 and 4 in the diagram, on the TV diagram, in this region we have a mixture of saturated liquid and saturated vapor. Since the liquid and vapor's phases coexist in equilibrium at these states, a vapor that is not about to condense, not a saturated vapor, is called a superheated vapor. This constant pressure phase change process is illustrated on TV diagram in figure 3.11. For example, we talked about compressed liquid or subcooled liquid, then saturated liquid, saturated mixture, saturated vapor and superheated vapor. So this is the TV diagram, property diagram, temperature, volume diagram. So here we have temperature in degree centigrade. From 20, at 20 state 1, the water is compressed liquid. At state 2, here the water is about to vaporize, which is saturated liquid. We have temperature 100 degrees centigrade. So at state 2, the phase change takes place from 2 to 4. At 4 we have saturated vapor, and in between these 2 and 4 states we have saturated mixture. And from 4 to 5 onward, from state 4, if heat is supplied to the steam, then it will become superheated vapor. So this is at 1 atm pressure. These states are given. Similarly, we can define saturation temperature and saturation pressure. So at a given pressure, the temperature at which a pure substance changes phase is called the saturation temperature, represented by T is AT. Temperature, saturation temperature. Likewise, at a given temperature, the pressure at which a pure substance changes phase is called saturation pressure. So this is all about the phase change. At which point the phase change starts, respective temperature and pressures are called saturation temperature and saturation pressure. This is the PT diagram, saturation pressure and saturation temperature diagram for water. In tabulated form, we have values, temperature in degrees centigrade and pressure in kilopascal. Say at -5 degrees C, we have 0.40 kilopascal saturation pressure. Similarly, going down to the bottom, we have variation in the values. For example, at 100 degrees C, we have 101.4 kilopascal value of saturation pressure. Similarly, at 200 degrees centigrade, we have 1555 kilopascal value for saturation pressure. So plotting them on the diagram, this is the saturation pressure and this is the saturation temperature. So the trend is, you see that the curve is an exponential curve. With the increase of temperature, here is significant increase in the saturation pressure. As we go down in the table, you see temperature increases, saturation temperature also increases. Latent heat and sensible heat. The amount of energy absorbed or released during a phase change process is called latent heat. Latent heat is responsible for phase change only in a substance. More specifically, the amount of energy absorbed during melting is called the latent heat of fusion and is equivalent to the amount of energy released during freezing. Similarly, the amount of energy absorbed during vaporization is called the latent heat of vaporization, and it is equivalent to the energy released during condensation. So, in all these processes, phase change occurs. That's why the word latent heat is used over here. The magnitudes of the latent heats depend on the temperature or pressure at which the phase change occurs. Similarly, sensible heat is responsible for temperature change in a substance. When we supply heat, and if there is no change in the phase and there is temperature change only within the substance, so we will say that this is sensible heat. Property diagrams for phase change processes. The variation of properties during phase change processes are best studied and understood with the help of property diagrams. So we can develop temperature volume, pressure volume and pressure temperature diagrams for pure substances. For example, this is the TV diagram of constant pressure phase change processes of a pure substance at various pressures, and these values are used for water. So say for example, we have pressure 0.01 megapascal, and by increasing the pressure, suppose we have pressure 0.1 megapascal, then pressure 1 megapascal, and pressure 8 megapascal, so on and so forth. So at these various pressures, the respective phase change processes are shown. This is the compressed liquid side. So this is from this state to this is the compressed liquid state. At these states, these are saturated liquid states. So if we join these states, this will make a line. This line is called saturated liquid line. On another side, if we highlight these points where phase change ends and join these points, we will get a line. This line is called saturated vapor line. These lines intersect each other at a point, so that point is called critical point. The region on this side is called compressed liquid region. This region is called wet region or saturated mixture region, and this line is called saturated vapor line, and the region to the right of this line is called superheated region. So it's very easy and convenient to understand now the various regions and different lines. This is again the TV diagram, as we discussed that this is the compressed liquid region, this is the saturated liquid vapor region, are also called wet region, and this is the saturated liquid line, this is the saturated vapor line, this is the critical point. These are the various pressures at which the phase change takes place, and this is the superheated region as discussed. This is the PV diagram for a favor substance. Sometimes it is necessary to plot various phase change processes on different diagrams on which it is convenient, so we can also draw it on TV diagram. So again, we have these lines which are constant temperature lines, and this is the saturated liquid line, this is the saturated vapor line, compressed liquid region, saturated liquid vapor region, and superheated vapor region. So we can plot various processes on properties diagram very easily. So this is all about the properties of pure substance, and next lecture will be on property tables or steam table. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.